solve this differential equation using power series method. So let's write out our equation y prime prime minus xy equal to 0. This can also be written as the square y all over the x squared minus x times y equal to 0. From power series, our y can be gotten as a0 plus a1 times x plus a2 times x raised to the power 2 plus a3 x to the power 3 plus a4 x to the power 4 plus a5 x to the power 5. So it continues to infinity, which results to summation n approaches 0 in our infinity sign. Then this becomes an x to the power n. Then the next one, since we are looking for the second order, we are going to differentiate this twice. We are going to differentiate this twice. So the next one becomes dy over dx. Y over dx. Differentiating a0, we get 0. So we start with 0. So the next one is a1x. Differentiating a1x, we get a1 plus 2ax. Next one plus 3ax to the power 2 plus 4ax power 3 plus 5ax to the power 4. It continues, then this becomes summation n approaches 1, then infinity, where
that n means that we are differentiating the x.
Yes. So n becomes n times our a and x to the power n minus 1. So this we differentiate it again. Since we are looking for the second order derivative, we are going to differentiate it again. So it becomes
this particular one.
Yes, we differentiate this one again.
Okay.
So it becomes the square y over the x squared. So if you differentiate this one,
0.
it becomes 0. So we start with 2a. Then differentiate this, we get 6. Our 2 multiplied 3, we get 6ax plus. Differentiate this one, we get 12ax to the power 2. Then for this one, 20ax to the power 3 to infinity. Summation n approaches to infinity. Then this becomes n. From this part now, this now move over to this part. Yeah, we're going to write n minus 1. Then our a and x to the power n minus 2.
Why is that so?
Sir?
N minus 1.
Okay, like just your normal differentiation now. Like if it's 2x squared, you're differentiating this one and this 2 will move here to multiply this one become your 4x. Then you're going to subtract 1 here. So here it becomes 2x. So the same method we're using for this one. Okay. Okay, for this example we are using from a0 to a5. It depends on the question. For them, you can use it to as long as you want, even to a10 if you wish to continue. So from here now, you can see that we'll add all these we'll substitute this into our equation. Let's say this is equation 1. We're going to substitute the value of y, dy over dx, the square y over the x squared into equation 1. But putting all this into equation 1 will look very lengthy, so we are going to use our results. We are going to use our results. So from equation 1, the square y over the x squared, which is this, and our result is the value of the square y all over the x squared and y into equation 1. So we can see from here the result of the square y all over the x squared is summation n equal to infinity n bracket n minus 1 a n x to the power n minus 2. Then from here we are getting minus x. Then we input the value of y. Okay, the result of y, this is the result of y, which is summation n approaches 0, infinity a n x to the power of n. Okay, from this part we are going to be using an approach called shifting. So we'll like move this, use our x here to multiply this x. So if x times x raised to the power n is the same thing as x n, then this power, this other x is raised to the power 1. So it becomes n plus 1.
Yeah.
Okay. So yeah, from our indices. So this part will be written as summation n to infinity n bracket n minus 1 a n x to the power n minus 2 minus, now since we have multiplied this, it becomes summation n approaches 0 a n x n plus 1. Then infinity. From this part now, we are going to look for a way to make our x raised to the power n minus 2 and this x raised to the power n plus 1 have the same power. We are going to look for a way, how can we make this become the same, have the same power? So for this other part, let's say let k be equal to n minus 2. Let k be n minus 2. Then if we want to, what is our n now? Our n will become k plus 2. K plus 2, if this one crosses over. So then this other part, let's say let k be equal to n plus 1. Let k be equal to n plus 1. Then looking for making n the subject of formula, n will become k minus 1. Okay, from this now, you can now substitute into this form. Therefore, we have summation. Now our n, this part now, our n becomes k plus 2. And we are going to equate it to 2. Therefore, from here now, from this n equal to 2, n here now is now k plus 2 equal to 2. So if these 2 crosses over, making k subjects, k will become 0 from here. So our k here now becomes k equal to 0, infinity. Then from here we now substitute the value of, okay, we now substitute the value of n. Substitute the value of n, which is k plus 2. Then this n becomes, we substitute the value of n here, which is n minus 1. Then our n here now becomes k plus 2 minus 1, becomes k plus 1. So here becomes k plus 1. Then our a, we substitute out the value of n, which is k plus 2 here. K plus 2. Then let's look power. Our n, since we say n is equal to k plus 2, we are going to substitute the value of n to this, which is n minus 2. If we substitute the value of becomes k plus 2 minus 2. So our power will be equal to k. So here will become k. Here becomes k. Then for this part, we get our summation to infinity. We say that for this part our n is k minus 1. For this part we say our n is k minus 1. Therefore, for this part our n will become k minus 1. That is k minus 1 equal to 0. Our k becomes 1. So here k becomes 1. Then from this place, we see that our a, and we say our n should become k minus 1 multiplied by our x, which is n. Let's substitute the value of n to this. That is n plus 1, and n is k minus 1 plus 1, which is k. Therefore, here becomes k. So we have succeeded in making the powers of x to be the same. We have succeeded making the power of x to be k and k. Therefore, from this now, we can now equate, we can now substitute k equal to 0 to this first part. Since this limit is 0 and this other one is 1, we are going to substitute this 0 to this k first. So from this part, okay, from here, if we substitute k to this, we'll be having 0 plus 2 plus 0 plus 1, then a, okay, 0 is 0 plus 2, then x to the power 0. Then this one will remain the same. Since this one is starting from 1, so we are now going to substitute the value of the k equal to 0 to this. So this will remain the same as summation k approaches 1, infinity a k minus 1, then x power k. Okay, from this will become 2 times 1, then this becomes a2. Then x to the power 0 becomes 1 minus summation k equal to 1 to infinity a k minus 1 x to the power of k. So this will become 2a2. This will become 2a2 minus summation k minus 1 to 1 infinity. Then a k minus 1 x to the power of k. Then from here now, we can now substitute, when k is 1, we can now substitute the value of k into this equation, into this summation. So from this other part, we are going to keep our 2a minus summation k approaches 1, then our infinity. From this part now, since we are going to put the value of 1, we are going to bring out this and bring out this. Since we are looking for 1, k approaches 1, it becomes k plus 2 brackets k plus 1 a k plus 2 minus this. It becomes a k minus 1. Okay, for this now, since our powers are the same, they will now be multiplied by x to the power k equated to 0. Equated to 0. Okay, we are going to equate this and this to the power of 0. We are going to equate it to 0, sorry. We are equating this, that is 2a2 equal to 0. And also, from this, a2, if we divide both sides by 2, our a2, that is 0 all over 2, a2 becomes 0. Then from this one, we get k plus 2 brackets k plus 1 ak plus 2 minus a k minus 1 is equal to 0. Then we are going to move this one over. It becomes k plus 2 brackets k minus 1 plus 1, then ak plus 2. When we move this one over, it becomes ak minus 1. Then we divide both sides by k plus 2 bracket k plus 1, because we want to make our ak plus 2 the subject of formula. So it becomes okay, from here, this will become, if we divide both sides, we will get ak plus 2 is equal to ak minus 1 all over k plus 2 bracket k plus 1. Okay. Okay, from this we can now look for the value of, from our y, let's remember we said y is a naught plus a1x plus a2 x to the power 2, and we stop at 5. So let's say 1k is 1, 2, 3, 4 to 5. And k becomes this. Okay, when k is equal to 1, from this we substitute k into this. So we get a1 plus 2 is equal to a1 minus 1. Then we get, here becomes 1 plus 2, 1 plus 1. And it becomes a3. a1 minus a1 becomes a0 all over 3 plus 2, which is a3 is equal to a0 over 6. a0 over 6. Okay, let's continue. The next one will be when k is equal to 2. When k is equal to 2, we get from this, k, if you put 2 here, it becomes a4. Then substitute a2 minus 1 all over 2 plus 2 bracket 2 plus 1. Then this part becomes a1 all over 4 times 3. Then this becomes our a4. Our a4 becomes a1 all over 12. All over 12. Then the next we have when k is equal to 3. Then if we substitute 3 to this one, we get a5. Get a5. Then it becomes a3 minus 1. We put our 3. Put our 3 there, becomes 3 plus 1 plus 2. Then 3 plus 1. Then this becomes a2 all over. Becomes a2 all over. This becomes 5 and 3, 4. Sorry, becomes 4. So this becomes our a5. Our a5 becomes a2 all over 20. a2 all over 20. Then the next, when k is equal to 4. When k is equal to 4, we get, we put 4 here, it becomes a6 is equal to a4 minus 1 all over 4 plus 2 and 4 plus 1. Okay, and this becomes a3 all over 6 and 5. So it becomes a3 all over 30. a3 all over 30. But if you watch, our a3 from here is a0 all over 6. So we're going to substitute this 1 over 30 multiplied by our a3. And our a3 is now a0 all over 6. Okay, from here, you can now multiply 30 times 6. Our A6 will become A naught times 1 becomes A naught all over 30 times 6 becomes 180. Then the next is A5. Okay, when k is equal to 5, we're going to put the value of 5 to this, which is A7. A7 becomes A7 minus 1 all over 7 plus 2, 7 plus 1. This becomes A6 all over 9 times 8. It becomes A6 all over 72. A6 all over 72. But you can see that our A6 from here is A naught all over 180. So we're going to substitute the value of A6 to this. So it will become 1 over 72 brackets. Our A6 now is now A naught all over 180. So 180 times. So A naught times 1. Our A7 will become A naught all over 72 times 180. We get 12,960. You can still continue. Remember what I said, you can still continue if you want to continue to A6. Huh? You said? You can still continue. Because if it continues to infinity, you can still continue. But let's just stop there for now. Then from here now, let's substitute the value of A1, A2, A3, A4, and A5. Let's substitute it to our first equation, which was y equal to A naught plus A1x plus A2x squared plus A3x to power 3 plus A4x to power 4 plus A5x to power 5, which went to infinity. Okay, we are going to substitute the value of A1, A2, A3, A4, A5 into this. Then substituting, we get this is A naught plus A1. Okay, from here our A1, we have the value. Okay, A1 and A naught, they are arbitrary parts, so they are like constants in power series. A1, A naught and A1. So this is A1x plus A2. Our A2, do you have A2? Okay, let's remember our A2 was equal to 0. Let's remember where we got 2A2 equal to 0. When we equated, then our A2 was now 0. So we substitute the value of A2, which is 0, times our x to power 2. Okay. Then next is A3. Then our A3, we have A3 is A naught all over A6 is A naught over 6 multiplied by our x to power 3. Then the next one, we have A4. Our A4 is A1 all over 12. A1 all over 12 times our x to power 4 plus our A5. Our A5, we are having our A5 is A all over 2, A2 times A5. And remember, we stopped at 5, but you can still continue since we have the value of A6, still the same thing as plus A6, that becomes 90 all over 180, then here will become A6. Okay, yes, A0, sorry, yes, A0. So we are going to select, take like terms of A0 and A1. We are going to take like terms. Therefore, for A0, why? Because we are going to pick all the terms related to A0. For this one now, we are having A0 here. So if you remove A0 from here, A0 it becomes 1. So the next one, let's see. Do we have any other A0? We have A0 here. So remove A0 here, it becomes plus x power 3 all over 6. Can be written like this. Then the next one, do we have any other A0? Okay, there's A0 here. Then it becomes plus x to the power 6 all over 180. Then there's no other A0 again. We close our bracket plus our A1 bracket. We have A1 here. It's multiplying x. That is x. Then the next, do you have any other A1? We have another A1 here plus x for all over 12. It continues. Okay, this is how we can use our power series to solve differential equation.